recording. All right, so let's look at the formulas for these shapes. So our circle equation is going to look like this. We have x minus h squared plus y minus k squared equals r squared. So hk is going to be the center of the circle, and then r is your radius. Okay, notice here, just this is what the equation looks like. There's no denominator. That's going to be the big indicator here. There's no denominator, no fractions in our circle formula. Okay, our parabola formulas are in here. So we've seen this first one here, the a x minus h squared plus k, where hk is your center. Now we're going to bring in these next two formulas, where you have x squared equals 4cy, okay, or x squared equals 4cx, and then bringing in a new vertex that's not 0, 0, you'll add in the h and the k. Okay, so really this c is this new thing, and the c is going to be your focus. The focus is just this point, and we're going to get into it a little bit more, but it's a point that's some distance from the vertex, okay, on the inside of a parabola. So like in this example, or these two examples here, if you had a focus, it would be like somewhere right here, a little point inside. And then this one maybe like right here, okay, inside the parabola across from the vertex. Then you have ellipses. So you've got a horizontal and vertical ellipse. Okay, look at the formulas for them. Looks like the formula for a circle, but you've got a denominator. Okay, so that's the difference between the circle and the ellipse. So if you have that formula memorized, just know the difference, then you can get your ellipse formulas. And then in this one here, this k, that should be a squared. For some reason, I think it probably transposed when it came over to be copied, but it should be y minus k. That's really what it is. It should be this here. I'm not sure if your guys' printout looks like that, but this should be y minus k, and then x minus h here. This is a squared b squared. I think that just came down when it copied from Word to PDF. Okay, and then we're going to look more into the difference between horizontal and vertical when we get to 10.3. Hyperbola, okay, those are going to be two parabolas that are facing away from each other. Okay, so if you look here, you've got sideways hyperbola and then up and down hyperbola. Now this looks exactly the same as the equation of an ellipse, but the difference there, do you guys spot it? Yeah, it's subtract in the middle. That's the only difference. So they're the exact same equation except for the middle sign here. So if you know the equation of the circle, then you can get the ellipse, which then you can get the hyperbola. So they're not too bad with memorizing. And again, we'll get into the center, the foci, vertices, all that fun stuff when we get to this section. Okay, but the first couple of pages are there to use as kind of a guide and formula sheet as you're getting used to them. So let's talk about circles. So we've seen circles before. We've got this equation here for center radius form of a circle, where you have r squared equals x minus h squared plus y minus k squared. Okay, h and k is going to be the center of the circle. R is going to be your radius. Circle's not a function, just note that. Let's just take a look at this example here. So we have find the center radius form of an equation of a circle with a radius 6 and a center -3, 4, graph, and give the domain. It's already graphed for us, and the equation is there. But we'll go through and we'll do this. So you're going to go in here and you're going to go x minus h, and that h is going to be this x value here of the vertex. So you're going to go h comma k for these. So it's x minus -3. So that double negative there will make that x plus 3 squared. And then plus y minus k, which is 4 squared. And then that's going to be the radius squared, so 6 squared, which is 36. Okay, so just keep in mind, if you're looking at an equation in this form, when you pull out the center, what are you going to do with the signs? Yeah, you're going to pull out the opposite value of the signs because the minus sign is part of the equation. So if I were to look at this equation and pull out the center, I'd pull out a -3 and a +4. Okay, so I have this is graphed. You will have to answer some questions about the domain and range. So the domain is just going to be, well, it's given to you on here, but it's going to be the leftmost to the rightmost value here. If you didn't have it already given on here, you would just go, okay, x is -3. So what is the distance of that radius? So -3 minus 6, negative gives you that -9, this value right here. And then -3 plus 6 gives you that +3 right here. So that's -6 this way, plus 6 this way to give you that domain. So that would be bracket -9, 3, bracket. And then you'd use the 6 as well with the range. So you'd subtract 6 and add 6, but this time to the y value. So 4 minus 6 gives you -2, which gives you this value right here. So you go down 6. And then 4 plus 6 gives you that 10. So the range, bracket -2, 10. Okay, when you're doing that. So the circle is always going to have a bracket. Okay. Now let's see what we're looking at here. Another example. Okay, let's say you want to put this in your graphing calculator, which you're not going to have too many of putting in your calculator here. We're going to do a lot of the graphing by hand, but mostly for the parabolas and the ellipses and hyperbolas. But let's say we want to graph this, you need to set it equal to y. So I would isolate the y, so subtract the x squared, take the square root. It's plus or minus in here. So if I went to graph this and I forgot to do the plus or minus, and I just did square root of 9 minus x squared, then I'm only going to get a half circle. Okay, so that's why you have to remember both. So then go down here and do minus or negative square root 9 minus x squared. And then that'll give you the other side of the circle. Okay. And actually, let's take a look at this equation. Let's get the equation. Well, actually, you already have the equation for it. So in this one, if you just take a look at it, this actually ends up looking x squared plus y squared equals 9 because our center is right here, 0, 0. So if my center is 0, 0, okay, then you have x minus, x minus 0 squared plus y minus 0 squared. So you don't need to write that. That just gives you x squared plus y squared. So if you see this without a parentheses, if you see the x squared and the y squared without parentheses, that just means a point at 0. Okay, so now what we're going to look at is the general form of a circle. So what we have here is where all of it is basically it's multiplied out. And you need to bring it back into that factored form so that you can graph and identify the center and the radius of the circle. Okay, so if I look at this equation here, I have x squared plus y squared minus 6x plus 10y plus 25 equals 0. So what we want to do is we want to find the center and the radius of this. So the process, we're going to go all the way back to chapter 1 of college algebra where we do completing the square. A little bit with that process. Okay, so rewrite the equation in those terms. So you're going to do x squared plus the cx, so the number in front of x. So in this case, that is x squared, and then you have the x is minus 6x. And then leave a blank because you know you're going to be completing the square, so plus blank. And I'm going to go ahead and put parentheses there. Then I've got plus, and then let's see, y squared. My y term, dy, is just 10y, so plus 10y plus blank. And then I'm going to take the constant, this plus 25, I'm going to move it over to the other side. So it's going to be equals negative 25. Okay, the next step is to complete the square on both the x term and the y term. So that is, remember, b over 2 squared on both of these terms. So I'm going to take my negative 6. I'm going to go negative 6 over 2 squared. So that's going to give me negative 3 squared. It's going to give me 9. So that means I'm going to do x squared minus 6x plus 9. If I add 9 on the left, I also have to add it on the right. So I have a negative 25 plus 9. Then I'm going to do the same thing for the y value. So I'm going to do positive 10 over 2 squared. So that's 5 squared, which is going to give me 25. So this is going to be y squared plus 10y plus 25. And I'm also going to add a 25 on the right side. Okay, next step is to take a look at both of these expressions on the left and factor them. They should both be perfect square trinomials. So x squared minus 6x plus 9 would factor to what? Yeah, x minus 3, which gives us x minus 3 squared. What about y squared plus 10y plus 25? Y plus 5 squared. And then on this side, negative 25 plus 9 plus 25, 9. Well, now look at that. Now we're in this center radius form. So now we can identify the center and we can graph and the radius. So let's go ahead and do that. Okay, so my h is going to go with the x. So what is my h value? 3. Good. I'm pulling the opposite value out. Minus sign is part of the equation. What about my k value? Negative 5, because it's y minus negative 5. So my center is 3, negative 5. What is my radius? 3. Good. Yeah, we're going to take the square root of this value over here. So it's going to be square root of 9, which gives us 3. And then we can graph it. I think on my math lab, you will plot the center with the circle thing and then do another point on the circle, or type in the radius. But here, it's probably going to be hard for me to draw. But here's how I typically do this. I find it, so 3, negative 5, 1, 2, 3, 2, 3, 4, 5. So plot your center, and then just go up, down, left, right, the radius. So up, 1, 2, 3, down, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then just draw a circle to connect those points best that you can. So a half circle. Yeah, not very good. We used to have compasses back in the day, but you know, I haven't seen one of those in a long time. Okay, and then if you were asked the domain and range, again, you can graph it and look at the graph. Here, the domain I think would be 0 to 6, or you can just add and subtract the radius from the x value and the y value. Okay, so let's do another example. And I think the other example has like almost the exact same values. So I want to change them up a little bit so you guys have something different. So it might not actually work out. So, but we're not gonna graph it, so that's okay. So let's change this to x squared plus y squared. We'll do a 12x. I don't know, we'll do 18y. and then minus 2. It's probably not going to have a nice even radius, but that's okay. Let's go through and do this. Why don't you guys try it out for a second, and then we'll do it. All right, let's take a look. So if I set this up to complete the square, it's going to look like this. We're going to go x squared plus 12x plus blank plus y squared minus 18y plus blank equals 2. Move that 2 over the other side. Okay, then I do complete the square. So what did you guys end up adding here? 36. Yeah, 12 divided by 6 is, or sorry, 12 divided by 2 is 6. Squared is 36. So plus 36 plus 36. What about here? 81. Good. So 81, 81. All right. What does x squared plus 12x plus 36 factor to? X plus 6 squared. Okay, what about y squared minus 18y plus 81? Minus what? 9. Yeah. Squared. And what is this? 119. Oh, is that prime? I think it's prime. Yeah, so, okay, what's my center? Good, -6 and 9. And we're going to say for the radius, that's just the square root of 119. The reason why I asked if it's prime is because if I could simplify that to like 2 radical 45 or something like that, you would. Okay, so, but this one I'm pretty sure is prime, so I don't think you can simplify that any further. So you just write square root of 119. It's not 119, remember, because that's r squared. So just square root. Cool. Any questions? All right, let's take a look at parabolas. Okay, so we've done parabolas a lot of times before. You've seen these formulas before. Okay, now we're going to look at some different parts of a parabola, so into even more detail with our parabolas. So you have a parabola that looks, you know, something like this. This is a set of points equidistant from a fixed point and a fixed line. So here's the center or the vertex of your parabola. The fixed point on the inside, so it's always going to open towards it, is called the focus. So this is your focus. And then the fixed line is this line, this arbitrary, that's invisible line that's going to follow the parabola. That's called the directrix. Just kind of like a, think of it as almost like an asymptote or a barrier line. Okay, and then here's the thing. The distance from this point to this point and this point to this line is the same. Okay, so this distance and this distance is the same. And that distance is c. Okay, so c is this new value that you're getting in here. And c isn't what the focus is, it is the distance from the vertex to the focus or to the directrix. Okay, it's the distance. And then the other thing is the sign of the focus will tell us how the parabola behaves. So if it's positive, the parabola opens up. If it's negative, the parabola will open down. If it's a left and right one, if it's positive, it would open to the right. If it's negative, it would open to the left. Okay, so we'll take a look at that. But that's what the focus and what the directrix are. So we're used to parabolas that look like this, right? Notice in both of these equations up here, the x is squared. So that's how you recognize also which way it is. So a vertical one that opens up and down still has x squared. Okay. Both of these are when, this is going to be for when your center is 0, 0, for these ones. Okay. So if you don't have that minus h and minus k in there, then you have a center of 0, 0 for both of these. Okay, the horizontal parabola, this one is a new one. So this one is either going to open left or right, like this or like this. That's when y is squared. Okay, so x squared, that's a normal one. We've been used to looking at that since probably 8th grade. Y squared, this is new. It's going to open sideways. Yes, question? About the what? It's 0, 0 for both of these, for this equation that I'm giving you right here. So if you just look on the next page real quickly, like down a little bit, you see the two new forms? It's got h and k in it. So because these ones don't have any parentheses or anything like that, we're just starting with ones with the center of 0, 0. Okay, so let's take a look at these. So these actually have the graphs down here, but I want to show you how to kind of go through these. So first of all, okay, you're going to look at this just to learn things about the parabola. This is x squared. So first thing you're going to say, okay, is x squared, which means this is vertical, up and down. Is it going up or is it going down? Okay, look at this. This is positive. Okay, so positive 8 means it's going to go up. Okay, now the equation. So go to the parent equation of this, which is x squared equals 4cy. Okay, that's what we had on the previous page. So 4c is what's in front of y. So now you're going to find, it's asking you to find the focus, the directrix, the vertex, and the axis. So you're going to start with finding the focus. So 4c is going to equal 8. You're going to solve for c. C is going to equal 2. Now, that is the distance from the vertex to the focus. Okay, so where is the vertex in this equation? 0, 0 in this one. That's a good shot though. Okay, so it's going to be 0, 0 because it's in this form up here. Okay, in this form up here, if there's nothing, so let me show you actually. Yes. So here's the equation, right? There's no HK there. So we just have the equation that looks like this, which means 0, 0 is that center. Okay, now if there are numbers there, then the center is different, or the vertex. Because in this equation here, there's no H and there's no K. Oh, I was like, it's with the mask, I can never see who's talking, so sorry. So yeah, do you see that though? So there's no H and there's no K in this, so that's 0, 0. All right, so we have the vertex is 0, 0. The focus is then the distance from the vertex. You can visualize it. You know it's going vertical. So let me see if I go down here. So you know it's vertical, 0, 0. So it's going to be 2 values up because it's going up. So you would just go up, and then you get the 0, 2 as your focus point. Okay, so every time if you look in this packet, there's a graph next to all of the examples, just because it's easier to draw everything out and then look at it as opposed to trying to. Okay, so our focus is 0, 2. The directrix is the same distance as the focus, just in the opposite direction. So this is going to go down 2 from 0, 0, and it's going to be a horizontal line. And a horizontal line is a y equals line. So that's your directrix. And then this is the x-axis, is your axis, because it goes up and down, like the x-axis does. Okay, let's look at the sideways one now. Okay, so Again, this has, so this would be y minus k squared equals 4c x minus h. There's no minus k next to this y, and there's no minus h next to this x. So my vertex is 0, 0. Okay, 4c, that's going to give us the focus. So I'm going to take this negative 28, and I'm going to set that equal to 4c. I'm going to divide by 4. I'm going to get negative 7 for my c value. Okay, so before I do that, it's y squared, which means it's sideways. So I'm going to say y squared is a horizontal parabola. Or you can just say sideways, that's fine. Okay, it's horizontal, which means it's either going to open to the left or to the right. So when I think about that, it's going to look like one of these. Negative 7 goes in which direction? Left. Okay, so if it's negative, it's going to open left. Positive opens right, just like the number line. Okay, it's going to follow along the number line. So this is going to open left because negative 20, we can say negative 28 or negative 7. Okay, so we know the vertex is 0, 0, and then we know the distance from the vertex to the focus. So if I come down here and I look at this, okay, I've got 0, 0, and then I'm going to go to the left 7 because the number line again goes left 7. So that point is going to give me negative 7, 0 for my focus. And then the directrix is going to be the same distance. So since I went left 7 for the focus, I'm going to go the opposite direction. I'm going to go right 7 for my directrix. And then since this is opening sideways, remember this has to follow along the symmetry. So this is going to be an x equals vertical line for my directrix. So the directrix is almost like this, like a barrier line that it doesn't cross, but it's either a horizontal or vertical line that follows the symmetry of the parabola. So this one kind of has this shape here, so it's going to have a horizontal line. Even if it was like this, it would have a horizontal line. So, and then this would have a vertical line, okay, because it's opening in the barrier towards that direction. Okay, because if I had this kind of line, it goes through it, which would make sense. So that's another way you can look at it. So I already introduced this a little bit when you have a different center, but this is your parent equation when you have a different center, so h and k. So in this one, you definitely want to graph it and count because you're going to get points for focus and directrix. Okay, so let's go through this example here. So this example, you're going to be given all sorts of different scenarios. So sometimes you'll be given an equation, sometimes just vertex and focus, all sorts of different things. So here, we're given the vertex and the focus and asked to write an equation. Okay, so for this one, let's look and see what kind of equation this is. So plot the vertex and focus to determine the parabola and the equation, because the parabola is going to open towards the focus. Okay, so if my vertex is 1, 3, 1, 1, 2, 3, that's right here. And then my focus is negative 1, 3. So that's this right here. So this is my V, this is my F. If I'm opening towards that, I'm opening, am I going up, down, left, right? Left, yeah. So I'm going to open this way. Okay, so I'm going to, well, that's not a very good sketch. We'll go red here. So I'm going to sketch kind of, going to go through, it's still not good. I'm going to go through that point there. You guys know what I'm trying to do. There we go. Okay, so I'm going to look like that. I'm going to open that way, which means, is this x squared or y squared? Y squared. It's y squared, it's sideways. So we're going to go y minus k squared equals 4c x minus h. Okay, the x is not squared. The only time they're both squared, the other three types of equations. So parabolas, there's only one line, only one of them is squared. Okay, so that's the first thing. The second thing is I know what the vertex is. I know the vertex is 1, 3, so I can plug that in to the equation. Okay, and I'll get there. But the next thing I want to do is I want to find C. So I need to find the distance between the focus and the vertex, which means I'm going to count. Okay, so I'm going to go on here and I'm going to count. 1, not letting me, 1, 2. C is 2. Okay, but you need to determine the sign. Did I go left or right? Which is what on the number line? Negative. So C is -2 because I'm going left. Even if you're in positive values and you go left, you're still going negative. Think about which way the number line, the directions go. Okay, so left is negative, right is positive. So my C is -2. And then I'm going to plug all of them into the equation, and I'm going to simplify. Just before I do that, another way that you could find the C, so algebraically, if you weren't looking at it, I like to look at them. I'm visual. But if you wanted to do this the other way, you could go like this. Right? You could go -1, so the focus minus the vertex. Okay, so focus minus the vertex. And then if it were up and down, it would be the y values. Okay, but the other values will be the same, so that can kind of clue you in. So you could do that algebraically as well. All right, so let's plug in everything we have. So we have y minus our k value, which is 3, squared, equals 4c, so 4 times -8, or sorry, 4 times -2 gives you -8, and then x minus 1. So that's our equation. Okay. So that's just finding a point. Okay, so the next thing that we have is this little bonus part here, this line called the lattice rectum. So what that is, I'm going to go up and I'm going to show you on one of these other parabolas. Is this, you see how you have these other 2 points on the line? This -4, 2, and 4, 2, that's the lattice rectum. I could move that, it won't let me, there we go. So the distance between those points. Okay, so that is the lattice rectum. It's a line segment through the focus, so it goes straight through the focus to points on the line. Okay, and it's equidistant from the focus. So how do you find it? Okay, the length of the entire lattice rectum is 4c, okay, where c is the distance from the focus to the vertex. Okay, so in this case, c was -2, so 4 times -2 is -8. Really can't have a distance -8, it doesn't really matter, so it's really the absolute value. Okay, so the distance from, or the length of the lattice rectum is 8, which means there's a line that goes through this point here, up and down, with a length of 8, which means half of the line goes up, the other half goes down. Okay, so to plot it, you're going to do this. We'll do this. So here's the focus. Here's the line. Okay, so this is the lattice rectum. I don't know who came up with the name. Don't ask. Okay, the whole length is 8, which means that this is 4 and this is 4. Okay, so you want to get those points. So again, you could go to the point where the focus is, and you can add the 4s to the y values to get the points. Again, I like to count it. So here I would go up 1, 2, 3, 4, right there. And down 1, 2, 3, 4, right there. which means that my parabola is actually going to look, I'm going to have to erase a few things, but we'll get that there. Okay, so negative 1, 3 was right here. Okay. So this is what my parabola is actually going to look like. So I'm going to go through this point. There's my vertex. I'm going to go through that point. So it just helps you to shape your parabola or get another point on the parabola. And then the question is, what are those 2 points? So that's negative 1, so negative 1, 7, and negative 1, negative 1. And the length, just negative 1 minus 7, 8, 8. So the length, just check that, is the right value. So let's do another example. So the second example that we have here, we have a vertex and then the directrix. Okay, so this one actually didn't ask for the directrix, but if I wanted to do it, I would just, actually, let's go back and do it just real quick. It would just be, if this is to the left, 2 to the right, 1, 2, this would be right here, vertical line, and whatever that is, 1, 2, 3, x equals 3. Okay, opposite from the focus, same distance. So here's the example. So write an equation for a parabola with the vertex, negative 2, 1. So negative 2, positive 1, that's right here. And a directrix, x equals negative 1. It's an x equals line. What kind of line is that? Vertical line. So again, that one's going to open there's my directrix. There's my focus. Or sorry, my center. Which way is this opening? Yeah, it's going away from the directrix. It's not going to go through the directrix. So the only way that it can open possibly is going this way. Okay. The distance, all right, so actually first, the equation, x squared or y squared? Y squared again, so y minus k squared equals 4c, x minus h. We know hk, we need c. So the distance from the vertex to the focus is 1. Yeah, because this was 1, so this distance here, it's hard to see. Okay, so the distance here was 1, so this one would be also 1. And then it's negative 1. Well, the point would be negative 3, yes. So the distance from vertex to focus, negative 1, because I'm going left. So left 1 equals negative 1. Okay, so C equals negative 1. So if I plug all of this in, which we're just writing the equation here, y minus 1 squared equals 4 times negative 1, negative 4, x minus negative 2, which gives us x plus 2. Okay, we got one more example and then we'll do practice. Okay, so focus and directrix again. So you have a focus of negative 6, 4. Yeah, there it is. And a directrix y equals 2. So it's through there, it is a horizontal line. There we go. So which way does this parabola open? Up. Good. So it's going to open up, which means is this x squared or y squared? X squared. Okay, so x minus h squared equals 4c, y minus k. Oh, that's the focus. That's not the vertex. which is still the same equation, but I just don't draw that part right there. Okay, so if this is the focus, there it is. Okay, and this is the directrix. Where's the vertex? Right in between. That's going to be right here. Okay, so what is this? What is that point? -6, 3, good. Okay, it's got to be in between. That's the only place it was in between. If it were more, like 4 values apart, it'd be 2 or 3 values apart, you'd have some fractions, but hopefully we won't have to do that yet. So you have a vertex of -6, 3, and then you want C, the distance from the vertex to the focus. So C, that's going to be this right here. What's that going to be? Yeah, just 1. Positive 1 because it's going up. There you go. See how it's easier when you are looking at it as opposed to trying to do it algebraically. So always have that graph handy or graph paper or start drawing it out just a little bit. So plug these in and then you get the equation. So we've got x minus our h, -6, so x plus 6 squared equals 4c. 4 times 1 is 4. Y minus k, k is going to be 3 here. So there's our equation. And let's go ahead and do the lattice rectum, just to go ahead and do that. Okay, so in this case, because this is opening up and down, it's going to be horizontal line, length here, length is absolute value of 4c, which is 4 times 1, which is 4. So this length here is 4, which means go through the focus. You got 2 here, 2 here. So here's my focus in black. So 2 to the left, 1, 2 would give me this point right here. And then 2 to the right would give me this point right here. Okay. And we'll go ahead and graph that. So here's the vertex. So my parabola is going to look like this through these 2 points. And then we'll go ahead and get the values for those points. So this -6, so that's going to be -8. And then 3. Right? Or no, what is that? 4. Yeah, -8, 4. And then that should be -4, 4. So those are going to be your points for your lattice rectum. And then I think that answers most of the questions about it. So you've got 5 practice problems. So let's work on those for a few minutes, and then we'll go over them. Okay, let's go over these. So the first one, we want to write an equation. Okay, we have vertex and a directrix. So if I'm looking at this, I'm going to plot my vertex of 3, 2. So 1. I'm going to zoom in a little bit, actually, so I can see this a little better. Okay. So 1, 2, 3, 1, 2. So there's my vertex. My directrix is y equals -2. So it's going to be through this point here. Let's go ahead and draw that. Okay. This is my directrix. This is my vertex. So let's count the distance from here to here. So I'm going to be 1, 2, 3, 4. Okay, so this is a distance of 4. Okay, this is my vertex. And my focus, okay, I want to find my focus, or my C is 4. I can find my focus. 1, 2, 3, 4. I don't think we actually really need that for this case, though, because we just need C. Okay, so that's going to give you C. So we have C, and we have our equation. Oh, last thing we need, what type of equation is this? X squared or y squared? X squared. It's opening this way. Okay, so that's going to be x squared. So x minus h squared equals 4c y minus k. Okay, so x minus 3 squared equals 4c. So 4 times 4, 16. Y minus our k value, 2. Okay, so that's all we need there for this equation. Let's look at the next one. So write an equation with a focus of 0, 0 and a vertex of 0, 1, and then what is the lattice rectum? Okay, so you have a focus of 0, 0. And a vertex of 0, 1. And if we're always going to open towards the focus, I'm opening which way? Yeah. So is this x squared or y squared? X squared. So x minus h squared equals 4c y minus k. My vertex, here's hk. I need c. How far is the vertex and focus? 1. Good. Yep. C is 1. So let's plug that in. So x minus 0 squared equals 4 times 1, y minus 1. So we'll simplify that. Yeah. Yes. It would be negative 1. Thank you. Good catch. Because we're opening down. So it would be a negative 1. Okay, so we simplify that. X squared equals negative 4, y minus 1. Okay, then what are the 2 points that define the lattice rectum? So the length of the lattice rectum is what? 4. So lattice rectum, we'll just go LR equals 4. So this whole distance is 4, which means 2 and 2. Through the focus. Here's the focus. So let's go ahead and erase these arrows that I drew because it's probably going to mess it up a little bit. There we go. All right, so 2 and 2, 2 left, 2 right. So then I can draw this a little bit better. Here's what my parabola is going to look like. I've got the points negative 2, 0, and 2, 0. You guys got good on that? Okay. All right, next one. We have this scenario here. So write an equation for a parabola with a vertex of 0, 0. Just go ahead and draw that. Axis symmetry is the y-axis. Contains the point 8, 3. Okay, so it's giving us a point. So let's see, 8, 3. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3. Okay, which means that this is either going to open like this or like this. So are we going to go sideways or are we going to go up and down? We're going to go up and down for this one, okay? So this is going to go like this. So if I have a point 8, 3, I've got another point negative 8, 3. And the axis of symmetry is the vertical line, or if it were different parabola, up or sideways, it would be a horizontal line that goes straight through the axis of symmetry, straight through the parabola. Okay, that one looks like a smiley face. All right, so we have a point and we have a vertex. We know it's going up and down, which means it's this equation. So if we want to find the equation of this, what we can do here is we can actually use that point as x and y. And then we have 0, 0 as h and k. Okay, so I have h, k, and x, y. And then that'll allow us to find c. So I'm going to go x, which would be 8, minus 0 squared equals 4c. Y, which would be 0, minus k, 3. Y would be 3, and k would be 0. 3 minus 0. And then we'll solve for c. So we have 8 squared. That's going to give us 64 equals 4c times 3. We'll do 4 times 3 and give you 12. Sorry, I'm just looking at my notes and making sure I did it right. Is x? Yep, should be good. Okay, and then 12c, divide by 12. What's 64 divided by 12? 16 over 3. Okay, that gives me what I have then. You have a confused look.
No, I was trying to divide it.
Oh, okay. All right, so 64, they're both divisible by 4? Yeah. So you can do that, or I'm just going to check it on here. Yeah, there we go. 64? Oh, sorry. Oh, yes, you do have to do that. Okay, so you get your C value is 5.3, which is 16 over 3. And then you plug that back into the equation. Okay, so we get our C value, then we plug it back into the equation. So you have x minus 0, which is just x squared, equals 4 times 16 over 3, y squared. Not y squared, just y. And then 4 times 16 over 3 would give you that 64 over 3. There's the equation of our parabola. Okay, and then we have one more parabola and then a circle. Hopefully we can finish on time. Okay, so find the vertex, focus, and directrix of the following parabola. So is this sideways or up and down? Sideways. You got y squared. This is sideways. Is it going to open left or right? Look at the 16. It's positive, which it goes right. Good. Okay, so what's my vertex? Switch it. 3, 2, because the h goes with the x, so that would be 3, 2. Good catch. So 3, 2. 1, 2, 3, 1, 2. Okay, we know we're going to open to the right. What is my focus? So we got to get our C, so we do 4C equals 16, gives you a C value of 4, which means I go right 4. So 1, 2, 3, 4, which gives you the point 7, 2. And then what's the directrix? Right here. Yeah, this is 4, this is 4. We're going to go through this up and down. X equals -1. And vertex, focus, directrix. There you go. So it's going to go like that. Okay. All right, and then real quickly, we will do the circle problem. So find the center and the radius. Okay, so we're going to group the x's. So you've got x squared plus 18x plus blank. And then group the y's. Y squared minus 8y plus blank equals positive 24. All right, 18 over 2 is 9. 9 squared is going to be 81. So we're going to add that to both sides. 8 over 2 is 4. 4 squared is 16. Add that to both sides. Okay, x squared plus 18x plus 81, that factors to x plus 9 squared. And then y squared minus 8y plus 16. Y minus 4 squared. 24 plus 16 is 40 plus 81. Okay, so center is going to be negative 9, 4. Radius, which is 11. So radius is 11. Good. Okay, so that's 10, 1 and 10, 2. Got through it.